So yeah, I will. So once this is done, I will then give my little intro, and then I will bring you into
Yeah, sure.
So yeah, thank you for doing this. This is awesome.
Yeah.
So, do I understand this correctly? You've gotten your doctorate now?
Yeah. Yeah.
Sweet.
That's really nice.
Congrats.
Yeah.
Well,
I'm doing a postdoc now. So.
yeah, Clive was telling me that you recently had a paper published.
Yeah, I've had I mean, we had two last week. Just working on a big nature paper.
How are you finding? Have you published in Nature before?
Yeah, yeah. I've done two in nature.
That's a pain in the ass. I don't know
Yeah.
how it is with in comparison to Nature to say AppJ or ANA. Nature is just a fucking pain in the nuts to actually jump through all the hoops and all that type of thing.
Yeah, and then the final paper of having to pay 11 grand, so we're struggling with that at the moment because our funding bodies have removed impact factor as a criterion.
Okay.
So, and they're now saying 11 grand can't be justified because we're not measuring by impact factor anymore, so they won't pay for it.
That's fantastic. All right, I think I'm gonna transition over.
Yep.
Howdy, all. Hopefully you can see me and hear me. Oh, apparently they can hear us. So during our during that intro. Anyway, howdy everyone. This is make sure that I have everything on the right place. Welcome to Coffee and Science. I am Dr. Rob, and I have with me the incomparable AB Science, Dr. AB Science. He is although we'll talk about it, but he has a YouTube channel. I'm curious if he's going to go back to actually making content. But without further ado, let me bring him on. All right. All right. Oh, and I should probably ask if you can all see me, hear me, and all that kind of good stuff. Because
It all looks good from my iPad I've got here, so.
I'll wait on this. I have to say that I don't believe that any of my research was ever funded by NASA. We can see and hear you. Well, all right. So M2M says they can hear us. Dr.
Fantastic.
Clive Wells says no, we can't.
Yeah. So now I'm on, they can't hear what I'm saying, what we're all saying, but they could hear when we're rolling the preview.
Apparently, yeah. All right. Well, we'll go with that. What was I gonna? Forgotten what I was going to. What I was going to say. Anyway, well, That's what I was going to do. I was going to say hello to folks in the chat. We have hello, howdy MTM, Arto, Dr. Clive Wells is in the house. Howdy Owlman, Reason, how you doing? George, Peter, and let's see, who else do we have in here? And I think I saw Dora earlier. So, okay, so apparently Clive can actually hear us now. So, all right, sweet.
Okay.
Well, like I said, welcome to Coffee and Science. This is what we are, or the reason why I've decided to do this is basically because I felt that with sort of current events, we're getting into a position, or we're moving towards sort of an era of expert denialism. Obviously, you and I know about flat Earth and have made videos or addressed people in the flat Earth community and the electric universe community, and so we understand that there is sort of this counterculture or the counter way of thinking that basically rejects mainstream science. And one of the hypotheses I have as to why that is that folks see us as something other, and they don't really appreciate that when they deny science and basically say that we're shills and we're all just bought off by NASA or whoever, that we're not actually real people. And so, kind of, this is just a conversation for folks to get to know us, essentially, and humanize us, as it were.
Yeah, no, that's a good one. I mean, we can talk about what's happening, why we're seeing those trends develop in society, but well, we can talk about that. But that will be a very long conversation because I think it's tempting with that to think, oh, well, this is the reason why we're seeing that. But there are as many reasons why that is happening as there are people who are into the whole woo peddling nonsense. So
yeah, I have my I have a couple of different theories about that. Going from, say, I think a lot of it is tied up into people's identity and in their feelings of significance, but I also think that there are a lot of folks out there who either started with or figured out pretty early on that they can make a buck. That basically this has become a monetary base. Basically, they're woo peddlers. They're snake oil salesmen. And wow, I can having a hard time talking today. But before we get into that, what I generally like to ask my guests a few questions, and so I'm going to start off with I usually start off with Star Trek versus Star Wars, but I'm going to just broaden that out to what is your favorite piece of just science fiction and why?
oh, my favorite piece of science fiction. I think I'm going to have to go for quite recent examples, although I realized the other day that one of the examples I would give is not that recent. That's 20 years ago now, and that will be Battlestar Galactica, the remake of it. What an astonishing show. I mean, I never really got into Star Trek. I kind of like it, but I was never passionate about it. Star Wars is entertaining, but I mean, I'll do blasphemy probably here for the audience, but those movies are profoundly bad movies. They are really bad. I mean, they're entertaining and, they're culturally valuable, but if you measure it by any metric, you would measure a piece of drama by or whatever, they're bad.
Yeah, if we're talking about Star Wars, the original trilogy, I mean, obviously I love those movies simply because I grew up with them. But
yeah,
the prequels, I didn't even watch Rise of Skywalker. I was so just disgusted with the Last Jedi or whatever it was that I was like, no,
yeah.
I'm done. I'm just completely just washing my hands of the Star Wars franchise at this point.
Yeah, I mean, I enjoyed, I enjoyed watching them.
They're pretty.
Yeah, they're pretty. But I think something that always sticks out to me is that anecdote from Harrison Ford where we went up to George Lucas, like, you can write this, but you can't expect us to say this.
I don't think I've actually heard that one.
Mm.
Nice. All right. Yeah, I think I would have to go with my favorite sci-fi so far is the Altered Carbon books.
Books, yes.
Yeah, the books.
I went through the first book after watching the TV show. I got into the and I thought, I'll watch the second season, and I didn't get along with it at all. It kind of lost a lot of the, and it just put me off kind of going further into the books. And
Yeah.
it didn't work out for me. I mean, I'm very big on The Expanse right now.
Oh yeah, I keep forgetting about
I think that is it's actually quite an important depiction of a society, and where we're headed. And it's particularly funny when you have certain billionaires who are going, it's like, no, who watch it and go, no, it would be really cool if we had that. And then you're kind of like, you do know what happens if we have that? We get space Hamas. And no.
I am curious, because with Star Trek, a lot there, from a technology point of view, a lot of things sort of mirrored Star Trek. I mean, people say that Star Trek sort of predicted the advent of cellular phones and things of that nature. So I'm wondering whether or not Expanse is going to do the same thing. But from a more, I guess, serious point of view, I am curious as to whether or not corporations or folks are going to actually try to use the Expanse as a blueprint for how to move forward in spatial exploration or solar system settlement, as it were.
Yeah, and I think, I mean, we see that a lot. And you especially just get that with, and to shit on our own discipline, right? You get that with STEM nerds who end up in a position of building a company and becoming successful. They're looking at stuff like this. They're looking at the kind of technology, and they go, well, it would be cool if we built that. And are completely missing the point of sci-fi. Because sci-fi is generally either a utopian vision saying, it's like, look what society could be like if we got rid of these petty little squabbles and the bullshit that we're dealing with today. Or the other side, it's like, no, if we carry on like this is what society is going to look like in the future. Be warned.
Yeah.
And they're completely missing the point.
Yeah.
And I think that's particularly dangerous.
That's the thing I love about sci-fi. When it comes to when sort of the debate among geeks or what have you, you have sci-fi versus fantasy, and the thing I love about sci-fi is that it allows you to, for me, for what I've seen, it is for some reason better fitted for social commentary. I really haven't seen fantasy be used to make any sort of commentary on human society or where it's going to go. But with sci-fi, particularly with The Expanse, I think it has a lot to say about how we are going, if we continue to go along this route, how are we're essentially tribalistic by nature, and moving to different planets and moving to different asteroids, we're going to essentially repeat the whole colonization thing and exploitation business again. So I agree with you. Yeah, to me, the Expanse is more cautionary tale than anything else.
Mm-hmm.
But yeah, I don't think Elon Musk has figured that out yet.
No. For some reason, I have a feeling that he's not actually a very smart man.
Yeah, I'm kind of with you on that one. I think that I think there are a lot of really smart people on SpaceX, but him, yeah, I think the jury's out on that one for me.
Yeah. Yeah.
But so how did you get into science? Like, I know, without doxing yourself or what have you, when did you know that you were going to get into science, and how did that kind of progress?
I mean, that's kind of a life story for me, right? I was always kind of interested as a kid in science. But at school, I was always like, well, biology, chemistry, that's the kind of thing for me. And I thought, biochemistry, that kind of thing interests me. I hated physics with fiery passion. And I dropped it as soon as I could. And then, so in the UK, you have your GCSEs up to 16, and you have 2 years of your A levels, where you narrow down your subjects and you go a bit more in depth, and then you go off to do a degree. And I chose to do biology and chemistry at A level, and that completely ruined it for me. So I left it. But I was also always very interested in music, and I was playing in bands and stuff at the time, and it was going quite well actually. So I thought I'd make a crack out of it, and I kind of ended up going into music. And then I did my first undergraduate degree in audio engineering. And I never really thought about really getting into science or anything until we started working with synthesizers. We started building synthesizers and coding, and it got to a point of, oh right, okay, well, if I want to make something out of this, building these things, I'm going to need to learn certain techniques, like understand how Fourier transforms work and all of those. So that got me into that. But then, I finished my first undergrad degree. Recession hit.
Okay.
Right, and this was a time with about half of graduates were unemployed. I managed to just about get a little job, low-level payroll stuff in HR. And I was just looking at the job market, and I thought, well, if I want to stand out, I'm going to need to get myself a master's degree. And I ended up choosing kind of a physics master's degree, medical physics. Ended up choosing that because I just looked at the course catalogue for the Open University. And I just went through the list of names, and I just looked at the prices. And I just landed up on medical physics, thinking, okay, I wouldn't hate doing that, and I can afford it because it was the cheapest course available. So I got in that, and through that I trained as a radio oncologist. And then I got to a place where I was like, okay, actually, I could see me doing this professionally, right? Radiation therapy and nuclear medicine, very interesting, and working as a medical physicist would be really quite exciting and a rewarding job. So I tried to get into that, but with the National Health Service, if you want such a job, you need two things. You need a master's degree, and you need a physics undergraduate degree, which is accredited by the Institute of Physics.
Okay.
So that kind of idea got shot. There was no way for me to pay for a physics degree, right? Because we've got student finance, but once you've already got a degree, they're not going to allow you to do a second one. And tuition fees just shot up as well. So there was no way of doing it. And I thought, all right, okay, well, I'm screwed. And I went up into kind of IT sales and consultancy, working for a few large companies, until I did get in a position where suddenly the money was available for me to do another degree, and so I went to do that physics undergrad degree with the intention of, okay, I'll do this. Once I finish that, I'll go into medical physics, be done. But then somewhere along the lines in second year, I think it was a bit of experimental, some of the labs, where we started playing with magnets, and kind of got interested, like, how does this work, and how does that, and what can we do with this? And then I started reading up on it, and I came across some people who were a bit for creating magnetic nanoparticles, attaching them to proteins, and then injecting them into tumor sites,
Okay.
and then applying large AC magnetic fields on it. And through the hysteresis
Hmm.
of a ferromagnet, you get lots of energy being dumped as you go through the loop, and you repeat the loop several times. And that heats up the local site, and that's how you can treat tumors. So then I was like, oh, this is interesting.
Yeah.
um, this is interesting, this is something I'd get involved with. And I started talking to people. And then when I was in my final year, I did a project on magnetic modeling. Figured out a few things about the systems that the research group I was doing my project with, what they were doing. And I think it was well. And then it was like, well, when you finish your third year, do you want to do a PhD with us? And
Yes.
yeah, that's how that ended up happening. Um, and I haven't looked back.
Awesome. Are you is your current research interest in sort of medical physics? Is it aligned in any way, or is it has completely different?
No, I mean we do a bit on the side for that work, but mainly we're looking at well, at the moment the project I'm working on, it's very much fundamental research rather than applied.
Okay.
Through my PhD, it was kind of two-sided. I did modeling of artificial spin ice systems and magnetic monopoles. And then the other side was to create magnetic racetrack memory devices.
Okay. I have no idea what those are.
Which we can go into, and that's actually one of those Star Trekky things, actually.
It's got a cool name, so yeah, I am very curious about that.
Yeah.
So is that so you are? That's what you're doing now. You're basically a postdoc at this point.
Yes.
Is that okay? Are you planning on going the whole traditional research route, or the university route of becoming a professor, teaching / research, or are you going to actually go into and try to make money and go into industry?
No, I mean, industry is not really my thing. I'm not opposed to it, but it's not my objective, right? Because if I was interested in money, I would have stayed in my old job before my undergraduate degree, because I was making twice as much money as I could ever hope to make in the next 20 years in academia, at least. So for me, everything I'm doing right now is just a hobby. It's just a hobby gone on steroids.
Ah, fantastic! I didn't really, I hadn't really thought about it that way. So what are the racetrack? What is this that you're dealing with?
Yeah, so I mean, these racetrack memory devices. I mean, I need to be able to draw. Let's see if I can find something to draw. But if you think, I mean, if you think about how magnets work, right? So what you have inside of a magnet is, well, each atom will have some magnetic moment, and in a magnet, you have these regions called magnetic domains, and all the magnetic moments are aligned in these domains. And then when you saturate a magnet, all the domains will start pointing in the same direction. And that's how you have this permanent magnet.
Mm-hmm.
But if we can create long, thin wires, and we can make the magnetization point either in one direction along the wire or the other direction, then we can have these small magnetic domains along that wire. And so you have a binary choice. Does it point left or does it point right? And we can detect orientation of that domain. And we can pass a spin polarized current through the wire to make these domain walls, make these domains move up and down the wire.
Okay.
So we have the solid state device where we have the magnetic domains move along, and then it moves over a read and write head. And the advantage of then storing that in a wire is that if you think about your traditional hard drives, for example, you've got a disk, you've got 2D surface that spins, you've got a read and write head. With this, you've just got this one-dimensional wire that you can fold up, and then you can store all of that information in the 3D volume. And that it allows you to save a lot more space. If you think about it, like, what is it, 90% of a hard drive, for example, is empty space or just gubbins to make it work, which is, you know, to make it spin, motors and stuff, which you don't necessarily need anymore. So you've got this solid state device in 3 dimensions where you can store your information. These things would be cheap to make.
Mm-hmm.
They're not volatile, so you know, if you think about your SSDs, you know, you unplug the power for too long, bye-bye data. You don't have that issue because it's still a magnetic medium, and you can hopefully achieve read and write speeds which are much higher. But one of the advantages, one of the big advantages for the future, is the amount of energy required to read and write a domain, to change the state of that. And that's orders of magnitude smaller than you would see in any kind of traditional storage devices that we see right now. And because it doesn't require electronics or heavy electronics with lots of resistance, we have less heating. And if you think about, you know, the if you think about what the energy costs for our computing infrastructures, where most of that is, it's some cooling systems for your servers to make sure that your hard drives stay nice and cool, and that reduces the requirement for that as well. So this is a very promising idea. It came out of IBM in 2008.
Okay.
And they've realized one-dimensional systems where you can store that, but the problem is that creating 3-dimensional structures is very difficult. And controlling and having that fine control over that domain wall as it moves along the wire, because you want to apply a current, and you want to know exactly how much movement you get out of that, and you want to exactly be able to reproduce those positions. And one chapter in my PhD was actually just about showing a proof of principle that we can create one of these wires in 3 dimensions,
Mm-hmm.
and then introduce little perturbations along the wire where these domain walls would get blocked, and they would do that every time, because you've got this issue of sometimes they'll pin at one of these perturbations, sometimes they don't, and being able to reliably pin them there in these places so you can read and write and do it reproducibly. And that's essentially one of my chapters. And then, you know, there's still there's a very long way to go for this to become a reality, but you know, that's how stuff like this happens, right?
Yeah, you got to start somewhere.
Yeah.
So with these drawings, are we talking about? I mean, obviously, would they have an increased capacity for storage?
Yes.
I would hope so. Okay.
Yes, but it's hard to draw the comparison, right? Because at the moment we're measuring, you know, number of bytes per square centimeter or whatever, and you know, we're dealing with different dimensions.
Yeah.
Because we're no longer dealing with surface densities, you know, volume densities. So it is a little bit different. But if you think about, just have one if you just think about the box that a hard drive would come
Yeah.
in that same box, we would be able to store orders of magnitude more data.
Okay.
And then with the promised read and write speed, which is a problem, I'll admit, but there are certain geometries of these wires where it is theoretically possible to achieve read and write speeds that are comparable to random access memory.
Okay.
So what that would mean is that essentially your computer architecture changes, right? Because right now you've got your slow hard drive and you've got your RAM where you store stuff for fast access. But imagine if your entire hard drive is as fast as RAM.
Okay.
But, you know, at the end, that's all pie in the sky stuff. It's, you know, the 10 years down the line stuff. It's always 10 years down the line.
Of course.
But in trying to solve this problem, you get some interesting insights into the fundamental physics, of course, and that's where the fun is to be had.
Nice. So your work was so what I'm getting is that your work was, you said, it's basically two kind of sections. One is theoretical and the other one is somewhat applied, or
yeah. So I mean, this racetrack stuff is very much applied. I mean,
yeah.
I'm kind of done with it for now,
Okay.
because the project I'm working on now is very much fundamental research. Yeah, it looks at vertex models and statistical mechanics and magnetic monopoles. So,
All right. Yeah, that's definitely not my field of study. But although I am kind of curious, as to, obviously as far as I know, we have never observed a magnetic monopole. Is that still accurate?
well, I mean, if you think about like the magnetic monopole properly as predicted by Dirac, no, we haven't observed it.
Okay.
But we do see interesting things happen in materials called the spin ice materials. And what they have there is you've got these materials where you have on the lattice you've got these tetrahedra, and these are corner sharing tetrahedra. So you know, you've got one and then another one which shares a corner, and on each corner of these tetrahedra, you have an electron, and its spin can either be directed towards the center of that tetrahedron or away from it.
Okay.
Now, and this arrives into the ice rules. We'll go into what that means in a minute, but essentially what you have is that the ground state is that you have two spins pointing in, two spins pointing out, and then you've got a region where there's no divergence in either the magnetization or the magnetic field. Okay. But thermal excitations, you know, so you have two adjacent tetrahedra where you have that rule being obeyed, but then a thermal excitation can flip the spin on the corner it shares, and then you've got one vertex where you have the three spins pointing in and only one pointing out, and in the other one you have three pointing out and one pointing in, and then you get this seemingly have this breaking of the rules, right? Because locally you have a magnetic field with non-zero divergence.
Okay.
And there's an interaction between these, which is like the Coulomb interaction, exactly as Dirac predicted, and they can move around the lattice, and you can have lots of exciting stuff happening with that. There's a problem though with these materials, is that they're really hard to study.
Okay.
And we can create magnetic analogs with it just using nanowires, where we instead of having single electrons, we can place nanowires in a lattice, and we can have a vertex where we have 4 nanowires where it can either point in one direction along the nanowire or the other direction. Okay. And it creates this interesting dynamic, right? Because you can arrange the magnetization in such a way that it tries to minimize the interaction between the different wires, but it can't happen because there is no configuration where if you've got your 4 wires, right? You can have this wire against a black background. You have this wire can arrange itself with this wire to minimize the interaction energy, and then it can do that, but it can't do that with the other wires.
Okay.
So what you end up with is that you have this vertex model where whichever way you arrange the magnetization, it can't satisfy all pairwise interactions. And that's something called frustration. And what that means is that we have different ways of arranging. And if the system is tuned right, then you have 6 different ways in which these can be arranged, and they all have the same energy. So what happens when you freeze the system down to 0 Kelvin is that you end up with this finite entropy at 0 Kelvin. And that's interesting, right? Because up until the 1920s, that would have been considered a violation of the third law of thermodynamics.
Yeah.
Until, well, who was it? Einstein and Dirac started having a little shout about it and decided, actually, no, that's probably not true. But, it's all based on, because we see this in water ice, for example, where you've got each oxygen atom has 2 hydrogen bonds with other hydrogen atoms and 2 covalent bonds. And there's 6 ways in which you can arrange this, and they all have equal energy. So when you freeze water down, you don't go down to 0 entropy. Yeah. And it leads to interesting physics. Okay. Put it that way.
So these ices, why exactly are they? What conditions do they exist in? Why are they hard to study?
Because you can't really probe down. Like if you look at the proper bulk spin ice, it's really difficult to probe because you have to do it at low temperatures to see the ground state ordering. And you have to do it in synchrotrons or synchrotrons, muon detectors. So you have to get your particle accelerators out. Okay. Whereas what we're doing with our spin ice, we're just printing some magnets, and we can capture a lot of the physics. Not quite, because we don't have something called the exchange interaction.
Okay.
But we can capture a lot of the physics in that by creating a model of the system in this way.
All right. I think I follow you that. Oddly enough, I've heard about and sort of read about the fact that these monopoles exist in these ices because of. Are you familiar with Ricci? Ricci 5.0. Ricci 5.0 is a flat earther, and
yes.
Yeah. And she, at some point somewhere, somebody brought up the fact that magnetic fields don't work on a flat Earth, and she was like, well, monopoles exist, and she actually pointed to a paper about this. She obviously didn't grasp what she was reading, but I looked at it and was like, oh, all right, this is fascinating, but obviously it's wouldn't work for the flat Earth. Would not be appropriate explanation for flat Earth.
Yeah, it's no. No, because even if you have, because I actually did do that modeling a while ago. It's like, well, what would we need to see? What would the magnetization of the Earth what would that have to be to get the magnetic field that we observe on a flat disk, right? Yeah. And a monopole doesn't do the job. A monopole doesn't work because that doesn't account for inclination. Okay. And actually what you end up with is a magnetic texture called a skyrmion. You end up with a giant skyrmion. And these are quite interesting defects in a magnetization. They actually do come in racetrack memory. Some people are exploring their use in that, but they're a bit problematic. But of course, these textures, you know, if their diameter goes above about 50 nanometers, they become energetically unstable and they just fall apart.
Okay.
But and also, if you want to stabilize them, you either need to apply a magnetic field to protect them, otherwise they will fall apart, or ironically, you need a curved geometry. Because curvature introduces effective fields.
Okay.
Yeah. So
Nice.
no.
Yeah, I did. I did appreciate the content that you've done on YouTube is kind of unlike anything else I've seen in terms of the debunking community, as it were. In that you've asked the question, all right, so they put forth this idea that we have a local sun, and so you then ask the question, all right, what would that look like? Can we actually create a model? What that would look like, and does that model actually match up to reality? Obviously, it doesn't. But it's I do appreciate the idea of treating these claims as valid scientific hypotheses, and then actually testing them in a rigorous way to essentially demonstrate, no, this is not how this is going to work. So is that something are you planning on ever revisiting, coming back to, or have you kind of left that the YouTube sort of creationist behind?
Well, I am looking at going back into creating stuff. I'm working on a few scripts, but because my priorities are a bit all over the place, and I've always kind of said, like, you know, I enjoy doing this YouTube stuff, but I don't want it to become a big thing.
Yeah.
Right? I don't want it to take up a lot of my time. It must absolutely not come at the cost of anything else, and it has to be a bottom of my priorities. I think I think there will be a point where I come across stuff where I can do that again. But right now, it's been a while since I've come across an idea where I can actually go from, well, what if we take that as true? What do we expect? Because, I mean, I like doing those videos. There's a kind of reason for it, right? I'm essentially making content for myself 10 years ago.
Okay.
What's the science outreach stuff that I would appreciate to see? Because I kind of started this just out of like, I want to do some outreach stuff, right? But if you look around, you know, what is the public engagement? What do we tend to see, especially in physics? And we're all talking about highfalutin interpretations of quantum mechanics or black holes and stuff like that. And it's like, well, I can talk about that. But not as competently as many other people will do, and they're already doing it. So what can I do? It's like, well, let's start looking at ridiculous ideas, because in every video I do, there is something under the surface that I want to communicate, right? So in the stuff about flat Earth, for example, and all of those things, it's not about actually debunking the claim, right?
Yeah.
I don't give a shit, right? You're free to believe whatever you want to believe. Whatever I say is not going to convince a flat earther, right? It's just not going to happen.
Yeah. I agree.
So what can I do with it? And it's like, well, you know, and I built this picture of the talented amateur, right? There's a person who probably, did better than average, the STEM subject at school, but didn't pursue it in later life. So we've got a certain skill set, and the idea is that basically I target it at people like they may not know how to mechanically differentiate an equation, for example.
Okay.
But at least have the intuitive understanding of what differentiation and integration means. right?
Okay.
You can have forgotten how to do that, but as long as you know differentiation, okay, you're just finding the rate of change. Integration, you're finding the area on the curve and all of those. Know what that means, and that's how I try to do it. And then actually, well, how do we take an observation or a claim and actually come with and develop a testable hypothesis from that, right? Because you see within flat Earth communities, like, oh, how do you test gravity? You can't, you can't use gravity as your independent variable because you can't manipulate it.
Yeah.
Like, okay, ignoring the fact that you're forgetting that observational methods do exist, right? We can figure out other ways of doing it, right? Because we can say, if A, then B, right? Then we observe B, then likely A is true. It's fine, but we can condense that. So if this relationship is a thing, then we also can expect this relationship. And we can test that and then implicitly test that.
Yeah.
And that's how we can build an evidence base. So, for example, we can then say, it's like, well, if the sun is small and local, okay, so what if we say, okay, we can't measure, size and the position of the sun, but from measurements we can take what, from solar flux and everything, what temperatures or what kind of climate would we expect, and then we find that the Arctic region would have to be a tropical area, beach holiday, massive beach holiday resort, and Australia would be a damp and dreary, messy place.
Be England.
yeah. Basically, Australia would be like England, and England would be something akin to California. So.
Yeah, that's an excellent way of putting it. In that, that's one of the questions when I have discussions with flat earthers, or mainly space deniers, is, that, as you say, they're like, "How do you test gravity?" And I try to emphasize that there's consistency. Like, not only does this law over here work, which we have observational evidence for, but as you say, we can take that relationship and then build up another relationship, which we can then test. That works. And so it's really just it's a building onto fundamental principles, and all of it seems to work. And it just doesn't seem like that quite clicks. They don't really have an answer for that.
Yeah, and that doesn't click. But, everything in science, because they're logically consistent ideas. And actually, one of the great implications of that is, of course, is that any experiment we do is not just a test of your hypothesis or whatever you're trying to test directly. It becomes part of the evidence base of the entire theory.
Yes.
Right? Because if we find something, and I know Clive's in the chat, and he'll say, don't let a bad experiment, ruin a good theory.
Good theory.
And that's to an extent true, because, if you get a null result, if you get something that doesn't support your hypothesis, it is actually quite difficult to figure out where it went wrong, even if you have a perfect experiment. There's just no way of knowing exactly then where the theory goes wrong. But that's all kind of issues around Popper's philosophy of science and the problematic aspects of that, of course, because it doesn't work that way. It's a bit more complicated than that.
I do need to read more Popper. I'm primarily concentrate on Kahn, or is it Timothy Kahn? Basically, scientific revolutions. I haven't really looked into, like, Popper seems to be more, Kahn seems to be overarching. Basically, what is science? How does science move? Whereas Popper seems to be much more, what's the word I'm looking for? Not localized, but more specific as to what makes science true, I guess, in a certain way. Like, what does one experiment have to say about the entirety of the scientific knowledge at that point? So
I mean, there are very problematic aspects of Popper. There, there is the idea that's like, well, every idea has to be falsifiable. Yeah, fine, okay.
Okay.
But then, yeah, as I said, right, if you get a result, you get results, you can't actually determine which bit of the theory is wrong. I can't remember the names. There's quite an expansive kind of body of work on that. I mean, obviously, this is philosophy of science, which, as an experimentalist, it's interesting to dip into once every other decade or so, but functionally, it makes no difference for us, right? It's like, yeah, you can have all your ideas, but shine a laser at it and we'll see what happens.
True. Yeah. As an observationalist, I can get behind that. I get it. I am becoming more and more of more and more interested in the philosophy of science. Although I've kind of, you were talking about priorities, that's actually kind of gone to the wayside. When it comes to the philosophy of science, what interests me is more of how it ties into science communication. Because to me, it's because one of the things, I'm sure you've heard this, is one of the things that science deniers really like to say is, well, you're not a scientist. You're not doing science right. And so I often ask them, well, how do you define science? What is science to you? And so I'm trying to find a way to understand where they're coming from, where they're getting this. If is it one particular source like Quantum Eraser, or is this something they organically sort of just arrive at when they first come onto the scene and are confronted by the fact that modern science is more complicated than they would want it to be. So for me, it's, philosophy of science is more of a way to trying to figure out how can I best explain what science is, how does it work, and what does it mean when we do get a null result? Does it mean that we can throw away the entire theory, or is it really just a stepping stone, or a crack rather, to look into to see whether or not, oh, all right, is this actually saying the underlying theory is wrong, or is it just something really weird that we've never really encountered or thought of before? So
Yeah, I mean, a null result, it does generally mean there's a problem somewhere.
yeah,
Right, and that's actually all you can tell, all you can say with certainty is that there's a problem somewhere.
yeah,
Don't know where, but it's somewhere, and then it gives us an opportunity to explore.
yeah,
But yeah, with the communication of science, I think a lot of people will have learned at school and even in science outreach. There's this picture, a picture that gets painted of science, how it works, but it is actually very Popperian, right? Someone reads, looks at the theory, they make a hypothesis and go and test it in a lab on their own, and then they measure the results, they write it up, communicate it, and the cycle repeats. But of course, that's not how it works, right? One example I would say, famously, is LIGO.
okay,
Right? It's an idea that they came up with, a long time ago. And then they figured out, okay, how can we measure this? How can we measure this? But you see the complexities because building the actual experimental apparatus itself is a scientific process as well, right?
oh yeah,
I spoke to a PhD student the other day, and her entire project is to figure out how one little crystal in the light path in the Japanese detector that they're building, how that works, and how the properties of that will affect the measurements, and and how can you correct for the artifacts that introduces. and that's an entire scientific project that
Yep.
she's working on. It's going to take her 3 to 4 years, and there's going to be other people who are working on that. And you just, you get this iterative cycle of, like, you've got your big scientific method, you can make that as one cycle, but actually if you zoom in on it, there's lots of little loops. There's lots of little loops and little tangents that go off and shoot in different directions. You see that reality is never that simple.
No.
And it's never done by one person, right? So we're working on testing a hypothesis that, well, we started working on it 4 or 5 years ago, right? And the first paper on it was, well, we can make this thing that may eventually help us test this idea later on down the line. It's a slow process, and you can say, oh, you're not doing science, but yeah, you can. And I think observational stuff, for example, is a fine example of that, because if you learn that Popperian idea of the scientific method, well, you can't do experiments. That's quite difficult.
Well,
but you can do more observations to try and disprove your conclusion, right?
So for astronomy or astronomers, ultimately what we get into, and this is again a problem that they have, is for us the experiment is modeling. We take these observations, and then we have to develop a model of what we think is physically going on, and we then get observables out of that model. We then compare those observables with what we actually observe, and if they're the same or if they're very, very similar, then we can say, what this model of what we believe is actually going on is what is actually going on. Obviously, with error bars or with some, it's not perfect or what have you, but that's essentially how observational astronomy gets done. So we're not manipulating. Well, what we are manipulating is the model itself, and unless you accept the fact that that model is a thing, can express or reflect reality in any way, if you can't accept that, then really you're not going to be able to do astronomy at all.
Well, yeah, and I would say actually, kind of like, even if you're doing like classical lab-based controlled experiments, the actual experiment happens in curve fitting.
Okay,
that's where the experiment is, right? Because I can tweak my independent variable, I can do whatever, and I've got these measurements. But at the end of the day, the validation of what's happening is in the curve fitting. And if you have, and even if you quasi-experimental designs, essentially, and that's what astronomy heavily relies on, you can derive almost the same kind of predictive power and even establish in the right conditions a causative relationship, right? And that's the only, because they'll say, astronomy is observational, and you can't determine cause. You can only determine correlation. But actually, no. If you have a system where you've got very well defined variables, very well understood mechanisms, then you can establish causation from observational methods.
Yeah.
But these are all slightly more nuanced pictures and ideas that Joe Bloggs on the street is not going to know about. And also, there's the idea of, well, this is the correct way of doing science, and this is again that Popperian idea. And then there's the wrong way of, doing science in their minds. But there is no right or wrong way, and our methods, what they inform is the amount of certainty we can have in our results. And we can see this reflected across the social sciences, where you've got you've got this level of confidence that they can have, which in, say, experimental physics would be sneered at, right? It was an outright reject, whereas it could be an amazing result in science. And as long as you understand the caveats that come with a result, then it's valid, because I think not enough people understand the importance of exactly the phrase that scientific theory is the best available explanation, and it's best available. That's such an important caveat to add, because we're not saying that scientific knowledge is perfect, not at all. We're saying that it's the best we can expect it to be, and it's just then a question of expectations, right? How good is the best you can expect it to be? And as long as you live with that, as long as you go by that understanding, and understand that as long as science is done in good faith, in a dispassionate manner, then you're all right. It may not be right, but it's better than nothing.
Yeah, one of the things with at risk of YouTube, whatever, one of the problems I saw with at least in the States when it came to communicating, COVID restrictions with the general populace, is the public seems to, or a certain segment of the population or what have you, they want certainty, which science is really never going to give you. Science is never going to, as people have said, never going to prove anything to you. It's going to tell you what is most likely. And if the scientist is honest, they're going to tell you this is most likely by some fraction. Either it's very, very likely, or it's not so likely, but it's the best we can do. Again, it's really whether or not the scientist is being honest. But the other issue, or the other sort of caveat to that, or continuation of that, is that science, because of that uncertainty, because of the fact that we don't prove anything, our understanding can change. And so with more data, our understanding changes, and therefore certain, with the COVID example, certain restrictions or certain guidelines have to be adhered to. Before we're saying, all right, masks don't, you don't need masks, don't hoard masks, because they're only really useful for the primary care folks. And then, as we got more data, we realized that masks needed to be more widespread. It's just this idea that, or this expectation that for some reason that science proves things and then writes it in stone, such that once a scientist says something, that they can't ever go back and change it. Or if they do go back and change it, then that means that they have no idea what they're talking about. So
yeah, and I think that's a problem, because people want certainty. And if we're talking about science communication and the problems in that, and we see that, we see that it's not a new phenomenon. We've seen that in climate change discussions as well on the news. You have a scientist come on, explain a thing, and they'll always couch it, at least if they're decent communicators, or not decent if they're correct communicators. They couch it in uncertainty, and the best available information and all of that. And there are rules that we have to live by in communication when communicating our work. And failure to follow those rules can actually have serious consequences. And even if we are right, just the fact that we're communicating it in a certain way can have serious consequences. But then you have the arsehole on the other side who's not bound by those rules, and they can talk in certainties. And it's a much more satisfying narrative for people who want certainty.
Yes. Yeah, and I don't know where that need for certainty comes from. I guess it's just sort of a comfort level that they, if too much is uncertain, they just start comfortable in their own skin in that regards. But
Yeah, but you see that entirely in in science denialism and conspiracies. Most of it, um, you can very clearly trace that a lot of it, the motivations behind it is around comfort,
mhm,
because it's about comfort and certainty. Because the reality is that life is scary, and especially if you know, if we are talking about conspiracies, you have this kind of, always this is talk about evil cabals and they and them,
yeah,
um, and that is why my life is shit, um, because that is emotionally a lot easier to deal with than the reality of the world's a fucked up place, and there are systems that exploit you. There are systems um, that you're participating in and propagating, just by the basic need of survival, um, that make your life worse.
mhm,
And the world is unfair and it is chaotic, and that is scary, because then you realize that no one's in control,
yeah,
right? And that's a terrifying idea. So it's easier to have the big boogeyman,
mhm,
which, yeah, it makes it emotionally easier to deal with, and also it's a cop out, right? Because it doesn't require any action from you.
true. You can just
And I'm not
basically
saying
say,
that's the whole thing, of
yeah,
course, as I said at the start. I mean, there's as many reasons why people fall into this line of thinking as there are people who fall into this line of thinking. But you see this as a common theme, because conspiratorial thinking, science denialism, it's easier to deal with. It's certain. It's safe. Um, yeah.
yeah. The one of I hadn't really thought of it in the sense of it being looking for comfort within a chaotic universe, because as you say, there are, we have, world is unfair. There are a lot of different systems out there that are built that are just going to run you down, and they may not be connected to one another. There is no single cabal or entity that is actually controlling all the strings. So there are so it's there's you actually have to expand your attention. You actually have to look more carefully at what is actually happening in your life, rather than just basically saying, "Oh well, it's because of the J people." I don't really, but what I get to, or what I'm sort of concerned about it, as it were, uh, is when I interact with these folks, what I am getting, or the impression that I'm getting, is that a great deal of their own significance, a great deal of their own identity, is tied up into these ideas, particularly those that tie faith to conspiracy theories, because the common example that I run into, and I actually run into this with just normal students, is I start off every year with Carl Sagan's pale blue dot quote. I actually have it up there on a poster. The basic idea is this was a Voyager image of the Earth as taken from Pluto, and he's talking about everything that has ever happened on our planet, in your life, in history, whatever, is on this pale blue dot. And when confronted with that, my students usually have one of two very different reactions. They either will look at that and say, "Holy shit, we are insignificant. There's no rhyme or reason to the universe. It's just basically chaotic nonsense." Or they might actually hold to my view is that we are actually exceedingly special, because we are essentially unique within this vast universe. And I don't know, it strikes me that in a sort of similar way, that folks that are on the flat Earth side, or and maybe not climate deniers, but vaccination, I don't know, science deniers, they feel insignificant in some way. And so this allows them more control in their lives to feel like they are more significant than they do. Something is disenfranchising them, is what I'm roundabout trying to get to. And I'm wondering what that disenfranchisement is, and whether or not figure out what that is and how that best can be combated.
Well, yeah. So, I mean, disenfranchisement is a different point, but the feeling of your insignificance within the universe. I have that conversation a lot with with people, and we're talking about that. But I think that feeling of insignificance within the scale of the universe, I think it is entirely misplaced. But I think that comes down to I think what that comes down to is this idea baked into culture. I don't know if that's just human, um, if that's just a property of how humans think about themselves and about the universe, or is it a facet of our culture where we grow up to think that we are special, we are above nature, there's us, and then there's the universe. And I think a lot of people will think of themselves that way, and it even is baked in language when we are separating things like what is natural and what is artificial. But if you think about it, like, we are not above nature; we are part of nature. So first, we can destroy that boundary of what's natural and what's artificial, because for something artificial to not be natural, that means that we're not part of nature, right? But we do it. We're organisms. We exist. We're natural things. Whatever we do, everything we do artificially is natural. It's part of nature.
Mm-hmm.
And understand that we are part of the universe. And you can then look at that image of that little pale blue dot, and you can feel insignificant, or you can think, actually, no, we are part of the universe. And if we see the universe as one thing, as far as we know, with the evidence that we have, what does this mean? Well, then, if we treat the universe as one entity, then we are that part of the universe that makes the universe self-aware, that makes the universe want to understand itself, and we are the mechanism by which it works. And if you think about it in that way, then actually you become hugely significant. It may be a bit worry and a bit kind of mystical, but I think there's a reasonable argument to be made to say that we are the organ of the universe that makes it want to study itself.
Yeah, I've talked with folks years ago, but I've talked to folks. Basically, the idea that I discussed with them was this, that life, the purpose of life, is really just is the universe trying to understand itself. It's the only way that the universe has to actually do that, or is at least the best way that we can conceive of the universe actually trying to understand itself, which is to me is a fascinating idea. As you say, it does get into mysticism and potentially into religious sort of debates, but which kind of brings me to kind of tying back around to sort of the significant thing. And do you feel that science communicators, or at least the heads of physics and astronomy, do you think that there's an arrogance there, that they actually do hold themselves to be better people because they understand physics better than everyone else?
No, I don't think so.
Okay.
I don't think they hold themselves as better people. I think because our top communicators, they know exactly where they are. They know exactly what they've done, what they've done to get there. And I think part of any good science training that you must have had to get to that position is the experience that, and I think a good scientist, the quality of a good scientist is recognize that you're an idiot. Just recognize that you're an idiot, and you'll get there, right? And I think there's a certain humility. I think there are problems around naivety within science communication. This idea that, well, if we can explain this to people, then they'll stop believing these silly things.
Okay. Yeah.
And I think that's naive. It ignores all of human history.
And from one of the other things that I'm looking at that I've also gone into is not only just philosophy of science, but also philosophy of teaching. And I can't exactly remember what the term is, but there has been teaching research to look into that, whether or not, you have folks that deny something. Can you change their mind? Can you flip them if you educate them more? And the answer to that is no. The answer to flipping somebody's opinion on something, on, say, the shape of the Earth, really cannot be done by educating them more, because there's something they're just resistant to it, and so.
Yeah, I think because I think there's a very toxic idea that you'll see especially in in scientific circles, and the kind of you also see it in kind of atheist Twitter, right? This toxic idea of being a rational person, and then the idea is that, well, you're a rational person, so just by becoming more educated, you can get rid of your irrational beliefs. But that's a fundamentally irrational way of looking at it, because your beliefs are not informed by rationality. I mean, you'll see this around you'll see this around Twitter, with the atheists and stuff like that, all kind of pretending that their atheism stems from a rationalization of the Bible and stuff like that, and religious texts, and from that concluding that no, there is no God, or I reject the claim that there exists a God. It's like, well, I don't think you got it. You got there that way. I think you got there because of it felt better. I don't know, because I grew up completely secular.
Okay.
I grew up in an environment where the very notion of religion was weird, right? You don't do the blasphemy thing just in case there is someone who's religious near you,
Okay.
and they might be offended. But yeah, it's a bit of an yeah. I grew up in an environment where it's okay. So my atheism is not based on logical thinking. It's just that's my default state. I've never examined that belief. It's not a rational. I'm not there because I don't have those beliefs for rational reasons, right? And I think a lot of people will end up using rationality to justify their emotional choices, because your beliefs primarily and your choices are more informed by emotion than they are based on data, based on reasoning, and all that.
Yeah.
So educating someone is just not going to happen. It's not going to make them change those beliefs. It's just going to evolve those beliefs, if you're lucky, and they'll try and warp that with it to fit their beliefs, right? You can have, and you can see this in the young Earth creationists, and when we're talking about evolution, it's like 10 years ago, you'd say, you talk about something involving genetics, and they'll struggle. But then some people went, actually, well, no, let's go and learn this, and then found some interesting way to try and incorporate this within my beliefs. But obviously, they'll end up warping the actual science to make sure that it fits their beliefs, rather than warping their beliefs to fit the science.
Yeah.
And that's how you get people like Kent Hovind who will bloviate about absolute fucking nonsense.
Yeah,
I mean, completely missing the irony, of course, that if you're trying to deny evolution, don't talk about genetics, because that is like saying cars don't exist by talking about engines. It's nonsense.
Yeah. Really, if you understand one, then you understand how the other one has to happen or has to be there. But yeah, I agree. For me, as a man of faith, I'm a man of faith not again because of a rationality or rational thinking. I am a man of faith because I have a personal relationship with the divine. How I got there, that's a topic of conversation for something else. But I find it interesting that you were saying that you don't really think that there is sort of arrogance among the sort of intelligentsia, as it were, because one of the problems I have with Neil deGrasse Tyson, whom I do not really care for at all.
No, I don't either.
Is that he's kind of an arrogant prick.
Well,
and one of the issues that I had, or one of the many issues that I had with him, is that he was on some kind of podcast somewhere, and he was talking about philosophy, and I think a philosophy major got on and asked him a question, and Tyson was like, "You're majoring in philosophy? Why? Philosophy has no purpose, has no use. Anything that philosophy asks, physics or science can answer." And I found that to be exceedingly narrow-minded and arrogant.
Yeah, I mean, I do say that. Sorry, you may hear my coffee maker in the background.
It's all right.
But I do say that based on kind of who I see, right,
Okay.
who I've interacted with, and also maybe a little bit biased. You've got people like Kip Thorne, Jim Al-Khalili, and maybe a bit biased because I know them personally. So
Sure.
yeah, yeah, I think Neil deGrasse Tyson is, I don't want to talk too much shit about him, but yeah, I do not care for him at all. And I think he does suffer. He can be quite easily accused of scientism, right? And that's not scientism the way that science deniers would use it, but
No.
Scientism in its proper definition of, science is the best way to answer certain questions, but not all questions can be answered with science. And as long as you respect that boundary, and it's that same thing, and it's the issue I've got with atheist Twitter as well. It's this appeal to science and stuff like that. Science says there's no God. No, science doesn't fucking say anything like that at all, right? We can use science to investigate and debunk specific claims made by a specific text. But the existence of a divine cannot be tested with science.
Yeah.
So do not talk about that in scientific terms. Don't ask for evidence for it, because it is outside of the realm of science. It has fuck all to do with it.
Yeah.
But if you are starting to demand scientific evidence for a non-scientific question, then you are entering the realm of scientism. And of course, conversely, right, you've got people who try and use science to prove the existence of God. It's like, no, you're being an idiot. There is no disconnect. There's no conflict between science and a notion of a God, right?
Yeah.
That's fine. I don't believe there is a God, but that's not my scientific opinion, right?
Yeah. I 100%. Oh, hi, Blue Marble Science. Blue says hi to both of us. I
Howdy.
am completely on board with that. I believe that my faith and my scientific reasoning are essentially completely two sides of a different coin. I do not go to the Bible to tell me how the sun is made or what the sun is made of, and I don't go to Bob big orange book, my introductory astrophysics text, to tell me why I shouldn't lie to people. There are two different ways of finding two different types of truth, and they really have nothing to do with one another. And it bothers me when anyone tries to bring science into a religious context, be it the atheist, be it people who believe in God. That gets to another. From a theological standpoint, trying to prove the existence of God is, to me, antithetical to Christ, because if you can prove God, then faith is useless, or faith is no longer important or necessary, and therefore, kind of Christianity as a whole crumbles. But that's besides the point. But getting back to the point of rationality is, I do have. That's one of the problems that I have with atheist Twitter, and that's something I've communicated with friends of mine who are atheists. Is that, what I get told, or the strong impression I get from atheists when I tell them that I'm a person of faith is, oh, well, you're a lazy thinker, or you don't think critically, or what have you. And I just kind of want to tell them to fuck off.
Well, yeah. I mean, one of the most impressive scientists I've worked with, and he taught me pretty much everything there is to know about how to use synchrotrons and stuff like that. Deeply religious man. Is retired now and put this grant, and actually, with his faith, informed and managed to ask questions and develop questions in biophysics, and he's doing some really impressive work with it. And to say that you can't be a reasonable thinker or a critical thinker if you're religious, it's just absurd.
Yeah.
Right? Of course, there are religious people who end up with their worldview and their view of religion, which I cannot see how a reasonable person can have those views. Of course, but yeah, it's just the mere existence of religion. It's not an irrational. It's not an irrational thing, or at least rationality has nothing to do with it. And I think you can really fall into a trap thinking that you're a rational person and that all your decisions and your beliefs are based on rational ideas, because then you're also rooting yourself into a position where, like, no, I am right because I'm a rational person, and it can be quite difficult then to accept, no, I'm wrong.
Yeah. If you believe that your logic is infallible, then you cannot entertain the notion that you are in fact wrong about something.
Yeah.
Depending on how well dug in your logical argument happens to be.
Yeah.
So.
I mean, there's one Twitter account I particularly enjoy. That's Pastor Alex Love with the whole Church of the Forgiving Eagle.
Okay.
It's a beautiful performance art, because I just really kind of dig in, and he'll post silly little things, like he did the massive smoke ring from a factory, and then going, if Jesus isn't real, then explain this, checkmate atheists. And he's a secular guy, and he posts this stuff, and you just get atheists just bombarding it, and just going, oh, you're such a fucking idiot, how you think about this for 1 second, and you just sit there thinking, and I sometimes will just prod it and poke it a bit further to see how far I can push them, because they're seen with their superior reasoning and stuff like that. If you had superior reasoning, look at his Twitter feed and you'll realize that most of it is about atheist cats. At what fucking point did you think that this was not satire? Right?
Yeah.
Because people will go, it's like, oh, it's really good satire. No, it's not. The satire comes from your responses to it, and you're jumping on it because you are so quick to demonstrate your superior logic and reason that you actually fail to apply it.
Yeah.
And it's beautiful. I love it.
I wonder if there is a what's the word I'm looking for? sometimes I think of certain debunkers or certain debunking communities. It's almost as if it's kind of a flip side with the flat earther debunkers. They both seem to have this need to prove how smart they are, and they basically are very dismissive about the sort of the other side. And it just becomes less about education or less. I don't want to insult anyone or pass judgment. I'm not trying to pass judgment on anyone, but it's just, to me, it seems like it's no longer really a discussion about flat Earth, globe, whatever. It's more a discussion about, I'm smart. This is why I'm smart. And I'm smarter than you.
Yeah, but you see this in scientific publishing as well, don't you?
Oh yeah, I mean
you see this fucking everywhere.
Yeah, pretty much. That is very true. So, and that kind of, to me, kind of ties back into that disenfranchisement, my disenfranchisement sort of hypothesis, as it were, is I think that with a number of flat earthers that I've talked to, or globe skeptics as they now start calling themselves, I just feel like they are, people look down upon them or don't think that they're intelligent people, and so they have to cling to this just far out notion on the off chance that maybe they actually are right, and so one day they can be like, haha, I knew something you didn't know.
Well, I think there is a multifaceted thing. So one of the one of the things that we can think about here is this notion of super secret knowledge, right?
Okay.
And that kind of addresses that disenfranchisement idea, all right? So if we're talking about talked before about control, about at least someone is in control and stuff like that, that's more satisfying than it's more satisfying, easier to deal with than a chaotic system, a system that we participate in and actually willingly contribute and propagate to. Hate to sound dramatic, but our own oppression, right?
Yeah.
And we willingly partake in that. But there's this notion of super secret knowledge. It's because, if you feel that people look down upon you, and that if you feel that people think you're dumb, then having this super secret knowledge, being part of this community that has the super secret knowledge, kind of gives you an ego boost, as well. And I think there's another facet which I'm kind of trying to. I'm kind of trying to make sense of it in terms of other movements that we see. I'm kind of toying with Guy Debord's The Spectacle, but also just punk, right? And there's this fetishization of being punk, being anti-establishment. And just having these counter ideas, because you have these words like sheeple, and we're talking about, it's all about against the mainstream narratives and stuff like that, and it's it is interesting because that again is appealing, right? Because then we can be the protagonist in our own underdog story, and we are there against all odds, and we're struggling on, and there's a romantic ideal that comes with that, and I think that is very appealing. Obviously, if you examine for most of these people their beliefs and stuff like that, there's fucking nothing punk about what they're doing. There's nothing anti-establishment about it, and actually they are just in a way propagating the systems that fuck them over, right? Especially when you look at the political alignment of many of these people at the moment. I wish there was, look back to the day where there were lefty conspiracy theorists. But unfortunately, right, because a lot of these conspiracies are actually they are almost a gateway into kind of fascism, in a sense.
Yes.
So you do have people that are then actively going into this with this idea of being anti-establishment and being punk, but then ironically, kind of ended up supporting movements and contributing to movements that go in the opposite direction to what is supposed to be that anti-establishment idea.
Yeah.
And that's kind of where I and it's not a fully fleshed out idea, or at least communicating this idea. It's not quite there yet for me. But that's where I kind of draw the comparison with Guy Debord's The Spectacle, of where you participate in something for the appearance of participating in it. It's that whole idea behind keeping up with the Joneses. But actually, it brings your own ruin, and it eventually will push you into something that you're completely against when you go into this. As I said, the idea is not completely fleshed out yet.
We
to kind of put an elegant and flowery description of what's happening, which is both potent and and it helps. But
well, I think I know where you're coming from with that. In the states, we obviously have Republicans and Democrats. For us, the Democrats are left and the Republicans are right. Obviously, in comparison to probably Europe, they're both right. But one of the complaints one of the observations, I suppose, that Democrats have about Republicans is a lot of Republicans are undereducated. They are impoverished, as it were. They don't have a lot of money, but they feed into the same system that's keeping them down. That basically they are because they are trying to be anti-establishment, anti-government. They want the government to stay away from them and all that. They inadvertently give power to the structure that is keeping them in the situation that they are now. And it in a sort of sense, it sort of leads into fascism, because when it comes to conspiracy theories, it's not hard to, particularly on YouTube, if you follow one particular creator, they may mention another creator, you can go down that rabbit hole, and that leads you into some really evil, dark shit, or at least as I've found. And
yeah, absolutely, because those pipelines exist, right? Because and if we're talking about fascism, right, fascism is syncretic, and what that means is that it is capable of taking ideas from other communities and other movements, and incorporate that in to make it seem more palatable to those people. So and we've seen this in the 2016 election, where actually we had a lot of Bernie bros completely being tempted into really far right thing by the anti-establishment idea that Bernie Sanders was promoting, and what he's all about as a democratic socialist. But if that is entirely, if your agreement with that is entirely formed by this anti-establishment notion, then the bullshit from the far right can be very appealing to you as well.
Yeah.
And that's what you see with syncretism, but we also see it weirdly, with traditionally quite lefty New Age woo, and even like environmental groups, right? You've got this really big kind of eco-fascism that's rising up, of lots of kind of eco warriors who end up really swinging right and supporting that, and that's because of that syncretism. And it's really easy to see that pipeline if you look at, say, for example, Eric Dubay's BitChute channel.
Okay.
right? Because you got to remember that Eric Dubay, one of the big flat Earth dudes, he's got a rap album where he openly praises Hitler.
All right. I did not realize that. I knew that he was an anti-Semite, but
And
I didn't realize that he was that far.
Yeah.
Okay.
And if you look at oh shit, shit, I can't remember his name now. But if you look at
There's Nathan
the
Thompson.
Netflix documentary,
The Beyond the Curve.
yeah, Beyond the Curve, yeah, there's this scene. I think it's Nathan Thompson sits in the car and he shows his book and he goes 1984. He's probably never fucking read it, but anyway. And then it's that book, Edward Henry's Greatest Lie Ever Told.
Yeah.
Right, and it talks about all this flat Earth bullshit, but half of it is just plagiarizing the protocols of the Elders of Zion.
Yeah.
So that pipeline is very clear.
Yes. Again, it's you get into the idea that, as you say, there is an other, there is a boogeyman, and what they don't really talk about is who that boogeyman is. When you ask them who that boogeyman is, they're usually going to say or equivocate and say the government or what have you. But a lot of them, from what I'm gathering, is they know exactly who they are. They are.
Yeah, the funniest one is where they talk about the Jesuits, because they haven't realized that Jesuits are different than the other J's. They haven't realized that
actually,
they're two very different things.
Actually, one kind of doesn't really like the other. And it's what I sort of tying it back to the whole certainty aspect of it is, at least again, this is also very nebulous. I'm really just kind of armchair bullshitting at this point. Is this idea that of the needing of certainty, and in order to really be able to have certainty, you've got to silence any distracting voice or any dissenting voice. And so, to me, that's where the fascism comes in, is that you start getting people who essentially want even though they claim they want a democratic process, they want to be in a democratic state, really what they want is an authoritarian that they agree with, because then that authoritarian can basically just tell everyone else who's disagreeing with them to shut the fuck up. And shut them down.
And it's
completely.
also, and it is about that certainty. It's about simplicity, right?
Yes.
Because if we're thinking about, they, right? That is easy. It's an easy idea to understand. There's this elite cabal that's keeping us down.
Yeah.
Rather than actually appreciating, there is a complex economic system, which has got a life of its own. You can almost treat it as a sentient creature with its own motivations and desires.
Yeah.
And there's a very complex system in place that no one can control. And that's scary. But what it comes down to is that is a simple idea. And
it gives them
economics is difficult. And we see that a lot with very populist talking points and very reactionary talking points. Is they're simple.
Mm-hmm.
Because they're simple, they're certain. For example, if we look at the discussion around gender identity, right? You've got one side which says, no, there's man, there's woman, it's simple.
That's it. Yeah.
It's not.
No.
It's not a simple thing at all, right?
I mean, it's not simple from a biological standpoint. It's not simple from a sociological standpoint. Yeah. It's messy. It's complicated.
Yeah, precisely. Because, and it makes it difficult to kind of convince people of that. And also, the simple message is easier to communicate.
Yes,
right?
It's very difficult to actually put nuance into an understandable context.
Yes, and I think actually, Obama in one of his books talks about this at length, actually, about difference in talking points. Because, you've got the idea of pull yourself up by the bootstrap. It's a simple idea, even though the phrase itself indicates how absurd it is, because the original phrase was intended to suggest that what it's supposed to imply is ridiculous. Impossible. Because you can't pull yourself. Physics.
It's not possible to do.
The idea and how the idea is simple and it's appealing, whereas actually the reality, it's far more complicated, and that requires some thinking, and it requires being able to reconcile complex ideas, and requires a bit of higher order reasoning.
Well, and also to me, it requires a great deal of trust in that. With again going back to the Republicans and the Democrats, you have I think the power of the Republican Party is the simplicity of it. They have very, they have very clear defined positions on pretty much everything. And when I say everything, really all I'm talking about is maybe 6 points. No government, or very little government, anti-choice, religion in schools, that sort of thing. They have only a very small subset of ideas that they actually address. They have very simplistic or very simple solutions to those, and they can stay on message. They are monolithic almost. And they are able, that power, that monolith, that allows them to basically drive through their ideology to people. Whereas from a democratic standpoint, we always say diversity is our strength and what have you. Unfortunately, I don't think that's really, from a political standpoint, I don't think that's true. I think the problem that we have on the left in the States is we are such a plurality that we cannot get behind something. We cannot agree on how to do something. We get ourselves sort of in the weeds of the nuance, and we don't have that political power to actually combat the Republican talking points, because we're kind of all over the map. We are such a big tent party that we're just too big, too disorganized, if that makes any sense.
Well, yeah, because leftist infighting is not exactly a new phenomenon, is it?
True.
Especially with the Democratic Party as well, because you've got such a wide spectrum of things where you've got the kind of more left side, but then you've got Joseph Biden, who by any European standard is pretty right wing.
Yeah.
Right. So
like I said, in our country, we consider ourselves to have left and right. I think if a European looked at us, they basically we have center right and far right, or we're both just far right. But the thing, where I was going with that is, economics is a fine example. I know nothing about economics. Supply and demand, that's basically as far as I get with economics. For whatever reason, I am not talented at understanding economic theory, and I don't have the interest to become talented in economic theory. So what that leaves me is I have to trust what the experts are telling me. If they're telling me that I'm going into a repression, if I'm going into a recession, okay, well then that's what's happening. They tell me that taxes are going to alleviate certain economic pressures. Okay, I'm going to have to basically buy that. What I find with denialers, or science denialers, or conspiracy theorists, is that they take the opposite approach. They don't trust at all. They basically say, no, I know best, and that's kind of where this actually kind of goes back to why I created this sort of show. Is I don't understand why they have such a lack of trust in experts or established academia. Like,
Yeah.
I shouldn't trust economics or economists as much as I do, but I do put faith in them,
Well,
and whereas they don't.
I think, and it's something I've occasionally referenced, kind of a bit tongue in cheek, but I think there's a certain level of truth around it. And this is about this notion of trust in institutions, right? Now, if you grow up in a very grounded environment, in a grounded way, aware of your reality around you, then you know not to blindly trust institutions, right? Because incompetence and shitfuckery are widespread everywhere,
Yeah.
right? So, and I think for a lot of people, um, especially when we look at the 2008 downturn, I think a lot of people went through life doing great, having a wonderful time and trusting institutions. Now, if you've grown up with this idea, it's like, well, no, you need a healthy skepticism of that, of the media, of the institutions, of the government, then actually you'll be okay. But if you grow up with this blind trust of these things, then and then you've got the world's biggest economic crisis happening, where for a lot of people the rug is just being pulled from under them.
Yeah.
And then suddenly everything crashes down. It's like, oh fuck, I can't trust this.
Yeah.
Right. And they're almost overcompensating in the other direction of whatever they say now can't be trusted.
Mm-hmm.
Whereas people will have gone through life going, it's like, well, you're saying this, but I'm going to treat this with a bit of skepticism.
Yeah.
So basically, and I say this tongue in cheek, is that conspiracy theories are just people who discovered that the media can't be trusted far too late in life.
Okay. So you think they're just essentially conspiracy theorists, or just the pendulum has swung too far to one side for them?
Yeah.
And
again, I don't want to generalize this,
yeah,
but I think I mean, we can see this especially with a lot of kind of narratives when conspiracy theorists talk about their origin story of how they go into this, and it will say it's like, oh yeah, I trusted everything what the news was saying me, and blah blah blah, and then I woke up.
Yes.
And it's like, well, I'm sorry, I've never trusted what the fucking news is telling me. I always know to treat it with a pinch of salt. Right? Because
it's interesting.
They lie. They lie. It's simple as that. But just because they lie doesn't mean they're always lying, right? Because most of the time they're not.
Or they just simply get shit wrong. It's also possible. People are human. They just get things wrong. But it's interesting that you put it that way. That they woke up. They had a certain lifestyle, and then suddenly something happened. Some major event happened, and they woke up. What that reminds me of are born again Christians. Is that they are, they lived a certain life or what have you, and then boom, something happened. They had an epiphany. They found God, and now they see things as they truly are. And so to me there's an interesting parallel between sort of conspiracy theorists and fundamentalist religious views, or I should say how they get into it, rather. How they become. I mean, again, I'm talking out of my ass, but I do think that there is a lot of parallels between conspiracy theorist thoughts and how they get to that point, and fundamentalists, religious fundamentalism. So.
Yeah, and I think a lot of it comes down to wanting stuff to be simple.
Yeah.
And I mean that's a perfectly understandable desire, right? Wanting stuff to be simple is
comfort.
Very human. It allows us to understand it. I mean, at the end of the day, wanting stuff to be simple, is the driver behind human knowledge, right? The problem is that, like, if you don't do it right, then you get conspiracy theory nonsense. But if you do it right, wanting stuff to be simple, then you get physics.
Okay.
Right? Because then you get a system of investigating the universe and trying to break it down in as simple rules as possible so we can understand it.
Okay. I see what you're going at. Yeah.
And actually, I would say that actually a lot of the desires behind it and the motivations behind that then are very simple, and they're basically the same. It's just whether you're doing it right or not.
So, kind of changing topic a little bit is, I kind of I want to know your opinion on, kind of touching into we're talking about the nature paper and the hurdles that you kind of run into. What do you think are some of the biggest hurdles among, in science, or basically mainstream science today? Like, what are the dysfunction that preventing science from proceeding in a open-handed sort of way, if that makes sense?
There is the scientific community is there's a lot of issues around it. So one of the things, and it also kind of leads into kind of a distrust of the sciences, because we're supposed to be kind of this, it's supposed to be almost anarchist, right? It's the science that does things, and it's supposed to be completely lacking hierarchies. But I think throughout the 20th century, there's been a big creation of this ivory tower, and how science is portrayed in the media. And we still see that, right? Even 10 years ago with that fucking show, Big Bang Theory, about, just these fuckheads that are completely inaccessible, not human, right? Presenting scientists as completely different organisms, and science as completely inaccessible. That leads to a distrust of the scientific community, and B, portrays science as being not accessible.
Yeah.
Right? And there is still a generation in place in senior positions at universities who will still be very much into that kind of ivory tower culture, whereas you have younger generations who are, a bit more anarchist about it and a bit more progressive.
Yeah.
So I think one of the things is access to doing science.
Okay.
And that's both from kind of the picture of the public image of what scientist is, and this public perception that science is supposed to be hard. Well, science is as hard as you want to make it, right? Science can be easy. Science can be fucking difficult. It's you get to decide.
Yeah, and really, to me, it's and this is kind of where I was going with the arrogance ideas. That what I've encountered with a number of sorry to say physicists, not so much astronomers, but I do see them as astronomers more in physicists, is that they do put a whole lot of weight on logical, mathematical intelligence. Is that if you are intelligent in that way, you are somehow better than someone who isn't as intelligent in that way. And where I'm getting with that is, I think that any discipline is going to be hard or easy depending on the individual. Like, you obviously are a musician. I can't play a tune I can't hold a tune in a bucket. Like, to me, music is exceedingly difficult. Economics, as I've mentioned, is exceedingly difficult to me. But I think it's just because each of us has a natural talent for what we want to, what we can do, what we can accomplish. And so, with science, some people are just naturally talented at science, and others really have to work at it. And so,
but they're naturally talented at doing science in a certain way, and I think we need to need to explore, different ways of doing it, different ideas, people with different backgrounds, right? Because you're saying, having this traditional kind of very maths heavy approach and being very good at that, and there's a focus on that. It's like, well, I fucking suck at maths. I'm fucking awful at it.
Yeah.
But it doesn't matter. I've got different ways of doing things, right? My memory is awful.
Yep, mine too.
And that's kind of why I like physics, right? Because it's, keep things
You have
simple.
tools, and you don't have to memorize a whole lot of stuff. It's more of
precisely.
how you actually get to the answer.
Yeah, but I play. I mess around in the lab. I just shine lasers at shit, press buttons, see what happens, and do it, and try and figure it out in a systematic way.
Yep.
And then we can make sense of it. I understand. I understand the maths and stuff like that. Yeah, but ask me on the spot to present you with a derivation of ideas of what we'd expect. No, you can forget it. And also the maths, we work with is a bit too complicated to do that because we're not working with systems that are exactly solvable, right? So, you end up having to write code and stuff anyway. But so there's different ways of doing it, and so I think one of the kind of big restrictions is a lack of diversity, and it's not talking about and that is a thing that we need to be more aware of, the diversity and gender balances and and everything, but diversity is in ways of doing stuff.
Yes.
And I think if we can promote that, then we will get to a place where we can do better science. So diversity, but for that, we require accessibility as well. And it is hard for people to get into the sciences because firstly, there's a lot of talent that goes untapped, because if you think about it, right, how do we teach sciences at school?
Okay.
Well, my experience is it made me want to blow my fucking brains out. And I'm hardly unique in that. And completely killed off any passion for it, any interest I had in it. Because and that's also at a university where we're kind of getting our first year students in. And it's like our stated objective of first year experimental physics, when we teach that, our first objective is to undo all the egregious damage that the education system has inflicted upon these children and restore that 6-year-old who is curious about the universe, because otherwise it's screwed. But that is only to the students who we get in the lab at that point, right? We can only do that to them. For 98% of the population, it's too late, because they won't reach that point. They won't get there. And in that 98% of the population, there are people who would have a skill set and an approach of doing things that we are entirely squandering.
Yes.
And so that has to do with how we teach science at school. And actually, my argument for it is, let's teach less science at school.
Okay.
Right, because what puts people off of science? Oh, just got some arsehole at the front of the class ramming down useless facts. Like, I don't need to know about the Krebs cycle, but they don't learn about the philosophy of science.
Yes.
Right? They just get, oh yeah, here's your scientific method, blah, 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 blah. Fine, learn that, that's cool. And it's like how it's actually done, and we're taking experiments out of the classroom, and it's entirely the wrong way of doing it. And I think the way we teach science, at least in the UK, I think there's too much of it.
Okay.
And it's also wrong. It's not the right stuff. We're not teaching the right stuff.
Yeah.
So that kills a lot of passion. Then how we portray scientists in the media, it's hugely problematic.
Mm-hmm.
And then the costs associated with it, right? Because we've got tuition fees and a good physics program here in the UK. If you want to do a good physics program, it means that you're going to live in an expensive city,
Yeah.
right? I mean, university cities are hardly cheap anyway, but you're going to be at the kind of traditional universities, and that's just going to make life more expensive, and that's not accessible to a lot of people. We have finance programs, student financing and stuff like that, and loans. But I can tell you, in my first degree, where I was living, I walked away being hugely in debt, and not just student loan debt, just for the fact that the loans and student finance I received covered 2/3 of my rent. The rest I had to make up myself.
Mm-hmm.
Right. So day one, day one when I started, I was £500 overdrawn all of a sudden. Right.
Yeah.
I'm just in the city. I'm completely overdrawn. What do? I just paid rent, and I'm screwed.
Yeah, I've got a roof, but I don't have any food. That sort of thing. Yeah, I hear that, and with the way that my sort of life story went, at least briefly, is that I got my master's degree at the University of Florida, and then shit happened, and I left. And then about 3 years later, I decided I was going to go back and get my PhD. But the problem was, while the tuition could be paid for, I had fees, and the stipend that they would give us wasn't livable. So at least not at that point. And so it came down to, yes, I either had to. It came to me that, all right, I got to a point, I was doing some classes, class here, class there, but then I realized, if I really want to take this seriously, if I actually really want to get my PhD, I'm going to have to leave my job. I can't do a full-time job and be a full-time grad student. It just doesn't work. And the reason why I chose the job is money. I could not afford at that point to basically just say, screw it, I'm going to become a grad student. I definitely understand the financial pressures with it, to pursuing higher education. I hadn't really thought of it, or I really haven't put a lot of thought into the representation of scientists in the media or whatever, and basically how we are sort of presented as other or hyper intelligent in order to do science, and I do think that so there is it does. I do have students like, I can't go into science because I'm not smart enough, or I can't go into science because I don't have the math skills, yada, yada, yada. And that does come in at a young age, and I don't know how to really combat that because I don't teach at high school or younger. But I definitely agree with you that we teach things wrong. Because, and this is something I struggle with, and I still haven't come up with a good answer for it, is that in college, damn near every science class I ever had started out with the scientific method. It got to the point that I friggin' hated the scientific method because they just kept regurgitating it at me over and over and over again, and then doing nothing with it. Like, they never tied in. I never had a course where they tied in the scientific method, as they described in the beginning of the class, to what we actually learned in the class. Like, how is it that we use this method to derive or to obtain the knowledge that we have? And so that's one of the things that I want to do with my classes, is to do that. When I teach astronomy, I am more interested in teaching them how science is done, using astronomy as a, template, or as words fail me, but I much would rather them come out of come out of my class knowing how science is done, liking how science is done, and wanting to do more. If that's in astronomy, great. If it's not, that's fine too. But I really want them to actually understand how science is done more than I want them to understand which stars are in the constellation of Orion, for example. So.
Yeah, and I think that is one of the issues. I think perhaps a lot of training is too focused, is too fact based, remembering facts and stuff. And I think that's one of the reasons why I hated it, because, as I said, my memory is shit. Right?
Yeah, I hear you.
I'm not gonna remember a bunch of facts and then regurgitate them on the exam. And also, I mean, if that's people's experience of science, can you blame them if later in life they become a science denier and saying that, oh, all you scientists just do is regurgitate facts?
Yeah.
Learn
from our religious textbooks. Yeah.
Yeah.
Clive says, I disagree with that. I see a lot of students that have really benefited from the way we teach science in schools. I think what he's referring to is, you were saying, particularly in the UK, that you guys teach it wrong. I'd be curious to know what Clive would want to expound on that a little bit. But
yeah, I think there is a lot of personal experience, because there are right ways of being taught it, right? Because I can say at school, when I did my GCSEs, right, I think biology, for example, my experience with learning biology was absolutely the right way of teaching it. But then when I did it at A-level, it was absolutely the wrong way, right? So there is personal experience, and I think there are people who are heavily motivated, and their teachers, what they have at school, it does really encourage them and light a passion. But I think you'll find that, I think you'll find that there are more people who have had a negative experience than a positive one.
In terms of science education, general science education coming up? Interesting. Yeah. All right. I had something and I completely forgot what the fuck it was. Speaking of memory blankouts, yeah, it was to your point of different. Oh no, now I remember what I wanted to do. When I was at Emory, I used to teach physics labs to pre-meds. And pre-med students were sort of a double-edged sword. On one hand, they had a work ethic that would make John Calvin blush. Like they just, they wanted to work and they wanted to get this stuff done. But the problem was they had come from a biological or a sort of what I refer to as sort of biological training in memorization. They want to memorize. That's how they get through their biology courses. That's how they get through their chemistry courses. So what they want from their physics instructor is, tell me every scenario that I will possibly encounter in physics, so that I can memorize it. And I'm like, you can't do that. You have to learn.
There's a reason why. You're talking about pre-med students, right? There's a reason why we don't classify medicine as a science, right?
Yeah.
If we think about it, the word STEM does not have medicine in it.
It's true. And it disheartens me, because I'm like, all right, so you guys are going to be my future doctors. And I think the most vital thing in medicine is diagnostic, is to diagnose a problem. And that's what physics is designed to teach you, is how to diagnose a problem and solve it. But they just want to memorize facts. And
but that's also in pre-med, right? Because within, you do hope, and that is generally accepted, that does happen, that eventually that skill set does come through.
Hopefully.
But just not at that stage, right? Because I say medicine is not medicine is not a science. You do have medical science, of course, and they will eventually go more down that direction.
Yeah.
But yeah, you do see that a lot. It's yeah, and it's quite understandable, right? Because these guys do, especially pre-med students, they do so much, and they have to learn. They have to learn everything as well, right? It's not that they can sit down and focus on just this one little thing, right? It's incredible what these guys have to learn, and there's a reason why it takes a bit longer.
Yeah.
Than most other subjects.
And some of them lose their friggin' mind while they're doing it.
Yes, absolutely.
It's I think when I looked at when I taught the pre-meds, that was the major sort of glowing neon sign of something is wrong in our educational system, because of the fact that they are essentially looking at science as a memorization exercise rather than a problem-solving building exercise. I don't know where that gets taught. I'm assuming at like the middle school, high school level, but granted, I'm not a biologist. I'm not a chemist, obviously. I don't know how to teach it in a way that it isn't just bulk memorization.
And I think there are a lot of teachers who would want to do it, because it's just even the problems that we're talking about in education, where do they arise from? It's because teachers are also not in a position where they can teach that way, right? And and as Clive said, a lot of people have had positive experiences, and what most likely is happening there is that the teachers in question have found ways within the confines of what they're expected to do, have found ways to teach the way they want to teach.
Mm-hmm.
Because I have spoken to many teachers, and none of them will say that, just this fact-based approach, just learning facts and facts and facts, is the right way of teaching it. And I mean, if we talk about conspiracy cats, right? I've spoken to him about that a lot. And it's his inability to teach in the way he wants to teach and teach real science kind of made it very difficult to enjoy the job.
Why does he? What are the difficulties that he runs into?
I mean, you'd have to talk to him about it, but it's a story that I hear from a lot of people where they want to teach science, but they end up teaching facts because facts are tested on the exam.
All right. Yes. Yeah. I was going to say that when you were talking about, I was thinking to myself, it's easier from an educator standpoint. It's easier to test on facts, and that gets into a whole different pedagogical discussion as to how effective are tests, how effective, particularly standardized tests, are these things actually useful in any way whatsoever? Do they actually gauge a student's how much they've learned, how much they actually can apply that knowledge? Who knows? I don't like.
I think
tests,
the best way to describe that is that exams are an awful way of testing and checking knowledge, but they are the best available method to do it,
and they are easier,
dispassionate manner.
Yeah, they're
right?
easier.
We haven't got a better way of doing it.
As far as not that I can see, particularly when you're talking about at the university level, if you're teaching 200 students or what have you, you're essentially, if you're going to do tests, you're essentially stuck with multiple choice because that's the easiest to grade. You just don't have the time to, say, give them short answer questions and have to just go through and by hand grade everything. But Clive kind of pointed something out. Clive states, I really wish I could figure out a way to actually highlight comments. Anyway, he states, if you give up teaching the difficult stuff in the UK, then future scientists will all be from China and Singapore, etc., because they have been taught at a far higher level. Um, do you think that's true?
Um, I mean, if we look at the just physics, right? Um, and how we structure our courses, I think we go over in our first year. We go over everything that been taught at lower levels, and there's a certain extent to which it's true, right? You do need to, you need to teach people stuff, but there must be a fine balance, because if you're dealing with a bunch of 17 and 18-year-olds, preparing them from university, they want to be fucking and drinking, right?
Fair.
And anything that stops them from fucking and drinking is just a bore. And the more you do it, the less passionate they become. So there must be a balance. It's like, yeah, there is stuff you can teach. There's stuff you should teach. But when it comes to it, not destroying someone's passion is, I think, the most important thing.
I see where you're coming from, and I think I see where Clive is coming from. Is that you have, it's sort of this the work ethic sort of perspective, in that you have this idea of, not to sound sort of verging on being racist here, but this idea that Asians are hardworking. They do science, and it doesn't matter how they feel about it. They're going to do it. But I also understand. I don't know how much of that is true, but I also understand where you're coming from, in that we do have a leaky pipeline. In that you're talking about those students in your lab that you can have more hands-on experience with, and really be formative to shape their understanding of physics, and to help them grow. But before you get to them, this is a sort of a selection bias. You're getting the most passionate students, whereas as you say, you're losing a lot of students along the way, because of the fact they just are getting bored of the subject matter, or it's just not it's not resonating with them for whatever reason. And as you say, you're losing. I'm kind of rambling here, but you're losing the plurality. For me, about diversity is plurality of thought, and I think the only way you get plurality of thought is through plurality of lifestyle, and that's where gender, socioeconomic standpoint, or status, race comes into effect. Is how people come through life shapes how they think, and then how they can approach the problem. So, kind of in summary, I think maybe what Clive is getting to is, if we don't teach the way that we're teaching now, if we don't lay it on heavy, if we don't try to teach the hard stuff at pretty much all levels throughout, then some other countries are going to do that, and they're going to be presumably putting out better scientists. I don't know if that makes any sense, but
I think that if we make science more accessible, and I mean, it's also difficult, right? Because we don't really have the capacity. That's another problem. We don't, we already don't have capacity to get more students in, right? So yeah, we can talk about making education at secondary level, making that science more accessible, but we still have a leaky pipeline because there's a finite number of seats available at the universities. But I think that there is a balance that can be struck. I mean, I'm not saying that we should completely, simplify and not teach the hard stuff. But the way we're currently doing it is not right. It didn't work for me, right?
Yeah.
It didn't work for me. It didn't work for so many other people I know. It didn't work for me. It didn't work for my wife. It didn't work for actually a few other people in our department. Eventually it worked out, but through a long, hard slog of rediscovering their passion for the subject that I had as a child and then go into the sciences.
Yeah.
But I also know a lot of people that just completely cut off and are now going, oh, I wish I paid more attention in school. I wish, I wish I engaged more with subject matter and had a better understanding of physics. And, I think there's definitely some changes that need to be made. Because I think if you want a passionate cohort of students, if you want a good cohort of students coming in, I think there should be a greater focus on allowing people to be passionate about the subject. And I think also, because on the flip side, you also see a lot of students actually who have just fallen into it, right? You see a lot of students who did well at maths, physics at school and stuff like that, and have just streamed into physics because it felt like the natural thing to do.
Yeah.
And they're just it feels to them like a path of least resistance.
Yeah.
And then of course come second year.
Easy.
Yeah. And come second year, they completely fail. And we can see the statistics, right? Because I did. Actually, that's a very good point. Because I did do educational research a few years ago. What we were looking at is, well, how can we streamline admission processes and what should we be looking for? And how effective is our more advanced education? Because what we're seeing, so in the UK, generally, what you do at A level, you take 3 or 4 subjects, right? If you're in a particularly masochistic school like mine, it's a few more than that.
Okay.
But then what we could just do, we just compare how many STEM subjects did they take at A level, and how is their performance at university? It's a very simple question. It's a very interesting question, and what we found is that there's pretty much the relationship you would expect between number of STEM A levels and degree outcome up until a point, right? So 1 A level, 2, 2 is better than 1, 3 is better than 2. But then we found something interesting. 4 is worse than 3.
Okay.
And then we start looking at, like, okay, so we've got this line, and then suddenly, and it's 4 is actually nearly as bad as 1. And what we start seeing is this divergence at second year, of where certain students started doing really well, and then we got this bimodal distribution of students who did really well and did really poor, and then the poor kind of group was dominated by people who did 4 A levels in STEM subject, and we then picked it apart, and actually the thing that caused it was when the 4th A level was advanced maths. And these are the students that mostly did chemistry, physics, mathematics, and then further maths, as it's called in the UK. And that's just the additional maths course where you can go into really cool stuff. And actually what we find is that those students consistently underperform across all STEM subjects. And the effect is the worst in the maths department, and then it's the physics department. And as your subject becomes less mathematical, that effect seems to disappear. So, you barely see that effect when you're looking at psychology or biology, but it's so pronounced, and it's really, the effect size is huge.
So you're saying that the more for shall we say the harder sciences, the more STEM subjects they take at A level at the A levels, the worse they actually do. Like once they get to instead of 3, they
Well,
go to 4.
superficially, that was the result, right? The more the more subjects they do better up until a point, and then it drops off. Their performance drops off, and it turns out that the causative factor is advanced maths. It is the further maths A level.
Okay.
And our hypothesis out of that was essentially rooted in complacency, because within the structures of how we teach things at university here in the UK, I don't know to what extent, because we've got a more pure approach, right? You guys will have your major minor systems. You're doing a physics degree, so you're going to do physics. If you're lucky, you'll get to do a little module to play around during the first year. But what we see happening, because we've got different exam boards, different standards, and during the first year, you get very much introductory stuff. You do your basics in mechanics, you do your basic electricity, magnetism, and stuff like that. The stuff you learn at school, just slightly more advanced, but the purpose is to bring everyone up into the same level. Now, the kids who will have done further maths, to them, this is not challenging. This is really easy, right? And you can see that because they do exceptionally well in first year. But then when it hits second year, right, that's when you stop going over the old stuff, and that's when you start learning new stuff.
Okay.
And that's where they fall apart, because they haven't had the challenge in the first year. So what are the other skills that are required? Right, it's that kind of work ethic, all the soft skills that come with that training that they haven't had to develop because they haven't had that challenge. And then you just see this divergence in performance in second year when stuff gets challenging, because at that point, your further maths A level is not going to save you. And that's when it falls apart. So I wouldn't say it's necessarily true that the more you learn, the better your outcomes are going to be. Now, if everyone had that training at A level and everything, then obviously you can adjust your courses for that. But it's just not. Are we going to force everyone to take those A levels? Right? I was like, oh, well, you're clever, you want to do physics, here's a list of A levels. Actually, no, I just wanted to do, like, English, for example. I wanted to improve my writing skills, or whatever. I'm interested in something.
Okay. So...
But yeah, this is a counterintuitive result, but it's heavily reproducible.
No, I get that. I'm just trying to think of how. So, it's what I'm really hearing is from that is you have, and maybe I'm just completely off, but with those students who basically get to that point and they get to that second level or second year and they can no longer rely on all the stuff that they have memorized or done in previous years, and they actually have to challenge themselves. Is that I guess where I'm trying to think of is, where does that come from? Is that because those students are not being taught essentially how to think and they're just memorizing? And so when they get to material that they have not seen before, they don't know how to cope with it?
It could be. Well, we don't know. We can't, from that data set, we can't tell that. We can, this is purely observational. We can speculate around what it is, but it seems that the most reasonable one is that enhanced skill set at first level, at first year, builds complacency, and they don't engage in a way that forces them to develop their soft skills like time management and stuff
Studying
like that,
skills
because they can
and
sail through. It's like, oh, there's an assignment, I will do that. Oh shit, I completely forgot. Oh, I've got to do it, hand it in 2 hours. Done, because you can do that. And then suddenly they're in a position. It's like, oh no, I've got assignments. I need to plan my week so I can, do everything in a timely manner. And it's just not developing that skill set.
all right, I see.
That's what we think.
Yeah.
That's what we think. We've speculated about putting in grant proposals to investigate why we see that effect. But this is I'm involved with this group of educational researchers across different departments, and for none of us it's our main job, right? So this always just bubbles in the background. And then pandemic hit, of course, and it's kind of completely fallen by the wayside. But yeah, we do see that, and I think it's quite well reproduced. I think I have seen it somewhere else in the literature as well. But yeah.
Yeah, here we have. I'm working with a few faculty members here in a somewhat similar way, in that although one of our faculty members is actually trying to move her research group from astronomy to actually involving physics education or educational theory, and so what we're dealing, or what she's really most interested in, is active learning. Is how can we bring active learning into the classroom, particularly the large classrooms, and how effective is that active learning environment in teaching these things, in essentially getting them to understand the material, and to learn the material, and then more importantly understand the material. But that gets into how do you actually test that. But I do understand that this is the idea of, this is stuff we want to know, but it's not our main job, so it kind of gets pushed off to the side. This we have been going at, I think, for 2 hours 40 minutes at this point.
Yeah.
Love the conversation. Would love to keep going. I just kind of I feel bad because I almost feel like I've been neglecting the chat. So I don't want to. I don't know who's all still watching, but if any of you have, I kind of want to wind this down. So if any of you have any questions for either myself or AB, please feel free to put that in the chat and ask us. We're not leaving yet, George. If you have any questions, please. So, is sort of educational theory, educational research something that you want to do further on?
Sorry?
Is educational research something that you want to do further on in your career, or is that just something that's
no, not really. It's just something that interested me at the time, and there was someone says like, do you want to get involved with it? And I did. It was for a bit of time. So Clive talked in the chat about all of their applicants do have advanced, do have A-level further maths, and I think but Clive, you also work in kind of a unique environment that is not quite representative of the other UK institutions. So because I think you require it, don't you, to have A-level maths, then you're not going to have that differentiation between your students. Unfortunately, not all colleges offer further maths. So actually, and then it becomes an access problem as well, because because certain universities will not be accessible if you don't have further maths A-level, And if you live in an area where there's no college that offers it, then you're kind of screwed.
Mm. Yeah, I don't know how much I really can't contribute to that because I am very. I know that you have A levels, but your system to get into colleges is significantly different than ours.
Yeah.
So, say that. Let's see. How does a frisbee fly? Indie Tiger asks. Bernoulli's principle. I'm going to go with that. That's going to be my answer to how a frisbee flies.
Yeah, makes sense.
So, where was I going to go with that? All right. Yeah. Again. Oh, yeah, that's right. I wanted to. That can lead us into the questions I have. Are what are your thoughts on basically free university systems, basically making bachelor's or secondary education free, and there's something else I want to ask, but about that because there's a push for that in the United States. I don't know if there's a push for that in the UK, but the Bernie Bros, they all want education to be completely free.
Well, I think that's the right way of doing it. I mean, you've got to understand that it's not free, right? It's supported through taxes, and I mean, in the UK, we had that system up until about 15-ish years ago. And then tuition fees were introduced, but they were heavily capped at £3,000 a year, and then later on they removed the cap raised the cap to 9,000, and actually that's putting quite a lot of pressure because the funding structures are a bit weird. I mean, yeah, I think it should be free. It should be accessible. We shouldn't put ourselves into an absurd amount of debt to gain education, and especially considering that the amount of value that a highly educated workforce brings to society, the economy, and how society works. Now, there is also, of course, the question of to what extent. Should it be free? I mean, are we talking about blanket all subjects? And again, I would say, yeah, actually, that's fine but I think there will be people who will say, it's like, well, yeah, you've got the valuable subjects. Maybe we should make them free, and then you've got the DOS
artist
subjects,
people have to pay for it.
Yeah. But basically, if you want to do the arts, then you've got to pay for it. But I think education should be accessible to all to people free of charge, and where we can select based on merit and choice, and not how much money and how much debt you're willing to get into.
I mean, ideally, I agree with you. Obviously, I think that from an ideological standpoint, yes, I believe that education should be free across the board at all levels. The problem the question I have for the states is we've never had a free education, secondary education system, as far as I know. So our institutions are built on a good deal of the funding for universities is through tuition. So how do we get? So my question is, how do we as Americans get from a tuition based to a non-tradition based without screwing over the professors essentially?
Yeah.
Do I have to take a pay cut because we're going to now make the teachers free? Because God forbid we gotta have football we got to pay the football coach $100 or $1 million.
Yeah, of
But
course.
so yeah, that's my only when it comes to that discussion. My main question is essentially how we're going to pay for it. How are we going to actually transition? Because again, that's the only system that we have right now. Obviously, state schools are state funded, so they do have some government funding behind them. But your private institutions, particularly your Ivy League, that all comes from endowments, or most either comes from tuition or it comes from endowments. Essentially, alumni, contribute money and so forth, and that starts getting into a loop of they get money. Their alumni are affluent, are more likely going to be affluent, so they have the ability to give money to the university because the university is prestigious. They're going to any graduate from, say, Harvard is going to get a better job or a better paying job than someone from, George Mason, and so forth.
Mm. Yeah. Oh, yeah. Clive put in a good correction. The tuition fees came in 1992. It was a bit earlier than I thought.
Okay.
But yeah, I mean, the simple answer is right. Like, how do you pay for it? It's through taxation.
Yeah.
And that's a difficult pill to swallow for a lot of people, and that's why it's not easy. But the argument can be made like, well, it is a public good to have an educated workforce. So,
well, another thing that I've considered is, and this will definitely have to be a conversation for another day, but is a general liberal arts education the right fit for everyone in this day and age? And what I mean by that is one of the problems I have my familial background, basically where my people, as it were, are very blue collar. These are farmers, these are people who work with their hands, and so one of the questions, or one of the objections they have is, how the hell is a degree in English going to help me milk cows, or going to help me back at home? And so what I'm wondering is whether or not our entire secondary education system really needs to be rethought in terms of in a way, how accessible is it? You have someone who comes out of high school, but is very their passion is something technical or technological. I mean, do they need to? So a lot of the classes they would take in the university would basically be wasted on them. Like, they don't care about English. They don't care about. They may not even care about theoretical sciences or biology or what have you. So is our current university system doing them a favor by giving them this big, well-rounded education, when really what they're most passionate about is just this one particular subject, and that's what they want to do and go forward with it. And so the well-rounded education is actually inaccessible to them, to what they want, if that makes sense.
Yeah, it's the breadth, not depth argument, isn't it? It's you can kind of see it's like, well, I think a well-rounded education can benefit almost anyone, regardless of what you do. It's and it's but it's also how do you perceive value, right? Because yeah, if you were saying it's like, well, how's an English training going to help me milk cows? It's not.
It's not. Yeah. Yeah. Exactly.
It's not directly, but you milk cows and you sell the milk over infrastructures that are built and managed and set up by people who do have university training. So you do take advantage of someone else's training, right?
Mm-hmm.
And that's kind of the argument why actually universities should be supported by taxes, because and should be supported by the state, because the infrastructure, right, the roads are built and designed by people who've got university training. And as a state or as a country, we are taking advantage of that and we are benefiting from that. And yeah, it allows the economy to run. So that is how people would, in such a situation, would benefit from people getting university training and making that more accessible. But it's how you compute value as well, right? Because you know, and this is actually about a higher order reasoning again, because like, well, if you look at it directly, no, it doesn't deliver value, but there's a wider ecosystem,
larger social impact.
Social wider social impact that is useful. And yeah, of course, a university education is not right for a lot of people, right? Leave, just want to milk some cows, even though I know there's way more to it, and there's agricultural science you know, a university training in agricultural science, for example, would be very beneficial there.
Exactly.
But
or say someone who wants to go into basically be a sound engineer is, you know, essentially a well-rounded general education approach good for that person. If they are really passionate about becoming a sound engineer or working in that field of study, shouldn't the secondary education be more tailored towards what they want, and everything else just is sort of wasteful? Whereas
but what do you mean with secondary education here? Sorry.
Bachelor's degree, master's degree, basically collegiate.
So, yeah, we would call that tertiary.
Okay, tertiary.
Yeah. Well, yeah. I mean, you can do it. You know, you can be tailored to it. I mean, I've got a degree tailored to that, but most of that, you know, was actually very generic, right? Because that is one of those. Because then we're talking about, are we vertically aligning by subject, or should we horizontally align, right? Because sound engineering, it's like, well, if you want to learn that, well, if you want to be well-rounded and to get tertiary education in that, then well, you need to understand music, right? Preferably, you know, you want to be able to play a few instruments. You need to understand, you know, you need to have a reasonable grasp of electronics. You need to have a reasonable grasp of acoustics. You need to have a reasonable grasp of business, a bit of programming. But you know, so you've got this really broad kind of background where you have a quite surface level understanding of different disciplines. And I think actually for, you know, that can be very valuable outside, right? Because, you've done this very specific training. But it does allow you to expand to different areas, and is quite broad. So it's breadth, not depth. Whereas obviously you have the traditional subjects, like let's just do a physics degree, then you go very deep into one subject, and that's it. But you know, my sound engineering degree, it taught me how to code. It got me into physics. It taught me how to run a business. So yeah.
All right.
It gave me entries into many other areas.
Okay. All right. Well, like I said, I think we're going to wrap this up. I love the conversation. Hopefully, people found it fascinating as much as I did. I'm a bit tired. I think that's the reason why I'm rambling so much today. Hopefully, I made some kind of sense. Anyway.
Yeah. I hope I did as well.
Before we go, one of the things that I'm going to put out basically an announcement on this. I am going to be. I have given a lot of thought to where I want to go as a YouTuber. Obviously, as you were saying at the very beginning, this needs to be a lower priority than I have given it previously. So I wanted to, because of that, I wanted to be more focused. I wanted to essentially, right now, my channel is really just a hodgepodge of a whole bunch of stuff. And really, what I want to do is really just focus in on a few things and do those well, rather than just having a hodgepodge channel. So I am creating two different channels. One of them is going to be, I'm going to be known as Professor Parks PhD, because I like alliteration. And that is where I am going to, oh, kitty! That is where I'm going to essentially have all of my SciComm content, astronomy, the coffee and science is going to move over to that. And then I'm going to have another channel called Mad Scientist, where I talk about basically just mental health and things that I feel passionate about. So, for those of you who are a fan of my channel, I'm going to be putting almost no more content on this channel, and I will be having two different channels where I will focus. I will keep the my two major interests separated from each other. So yeah. So you were saying, I guess to wrap up, you were saying that YouTube is really low down on your priority list at this point. So you don't.
Yes, it is. It has been for a while, but I'm putting stuff together to kind of come back and do stuff. It will be a little bit different. So the first thing I'm working on is actually kind of a bit more history of science stuff.
I noticed that on Twitter you basically post like a day daily as just sort of this day in science or this day in physics.
Oh yeah, I mean that's just a thing I thought I'd put in place because why not? Because it's just a little script that I've got running in the background on the server somewhere, and it just pulls. So the Institute of Physics have got this list of on this day, this and this happened, and it's just pulled that and it tweets it out every day. I need to kind of change it because I'm kind of bored of the. I've gone through the cycle 3 times, I think now, but I'm also kind of like less interested on this day that person is born. And I think I want to kind of get rid of that. I want to update it a bit and have a little bit more fun with it. I'll try that. There's some fun ideas I've got, but it requires a bit of creativity of thinking what to put in the place of those. But yeah, bringing it back to YouTube, I am working on something between the history of science, particularly around the turn of the 20th century, early 20th century. Okay. Because I think a lot of people and most activity on my YouTube channel at the moment is just Ken Wheeler fans and Electric Universe nutters talking about scientists in the late 19th century and early 20th century and talking absolute nonsense about them. So my first thing I'm kind of writing, I hope I'll get around to it, but it's quite a difficult subject because the source material is often quite questionable. But it's actually looking at Nikola Tesla over a series of videos and kind of looking at what he actually did. I was actually going to go with, why the conspiracy theories narratives around Nikola Tesla are completely absurd. But then I very quickly discovered that the popular narrative, and if you were to just ask a cross-section of people, which I did on Twitter, about what Nikola Tesla achieved and stuff like that, and even the popular narrative is beyond absurd. There's so many misconceptions around it, and it is an interesting story because this is a key figure at the start of the new physics. And a lot of modernization. So it's quite interesting what happened there.
I have to say, when I hear Tesla's name, Nazi death rays come into mind.
Nazi death rays. Yes. Yes.
that always, for some reason, that always pops in my head.
Yeah, no, that's actually not unreasonable for that to jump in your head because yeah, he did think about that for a bit, but not specifically about Nazis because he was actually good friends with a Nazi.
Oh, really? Okay.
Yeah, yeah, and actually that's the whole reason. So you've got this narrative of because he talked about this kind of death ray, and he was talking about it. Absolutely no work about it, but he actually was talking to a lot of people, managed to convince them that he had a real idea, and it was been on record and telling his Nazi friend about it. His Nazi friend got arrested, was in jail. And when Tesla died, there's a story that the government swooped in to kind of look through his work and see what's going on. And that actually makes perfect sense because the government knew, because the government probably genuinely believed that he was working on this big secret weapon. And he talked to his Nazi friend, and his Nazi friend was also a close friend of Hitler.
Okay.
So yes, there's this guy who's been allegedly working on this super secret weapon, and he's only 2 steps away from the enemy. But that was absolute nonsense. He was talking shit. There was no such thing.
Okay. Yeah, I don't know how much truth there is to it, but the thing that kind of sticks out to me with Tesla is that supposedly he went a little nuts later in life.
Yeah, I mean, later in life, maybe. I mean, going through his autobiography, I think there are very clear indications that he had some serious mental health issues throughout his life, and his coping mechanisms, because I think that's a key bit. His coping mechanisms were taken away from him. Because firstly, he was in poor health. He got hit by a car and that did an incredible amount of damage. But he wasn't a heavy alcoholic or anything. Like he wasn't like a drunk or anything. But he did religiously drink whiskey every day. And he said, it keeps him sharp. It keeps him, keeps him cool.
Yeah.
But 1920s prohibition hit, and a lot of stuff kind of got taken away, and he started practicing extreme veganism as well, which at the time was not really feasible. So I think a lot of his crutches were taken away. He was not leading a healthy lifestyle, and he struggled with mental health, issues, and it is very clear that those are issues that ran in the family, because he gave descriptions about his dad's behavior, his dad's character, and it becomes very clear that there's some stuff there, and he talks about how he identifies with it. And from my own personal experience, you can see the way he behaved. He had long periods of isolation, of working hard, sort of almost manic episodes, and then a lot of partying, and then other periods where he's very shy, recluse, and didn't do a lot, right? So you can kind of see where I'm going with that. Yeah. And left untreated, not in check, and not being aware of that is a thing, then complete with with old age and his mobility, because of his car accident, his mobility was heavily affected, so he became more insulated, and that's not good. So did he go mad? I don't like to use the word mad, but
I don't know, but
especially in later life with his he was not healthy. He was not in a good place towards the end of his life. It's quite a sad story.
Well, if you do a video on Tesla, I would definitely watch it.
Yeah, I mean, I've got one script nearly done.
Okay.
I think by the looks of it, it's going to be about three. So the first one, I'm really looking at the early years. So what happened in the 15 years after he moved to New York.
Hmm.
So we'll be talking about his work with Edison, his work with, well, with his own companies, and then things like AC motors, his invention of that, and
Yeah.
kind of misconceptions around that. And yeah, it's going to be quite cool. It's quite nerdy, but if you're interested in it,
Yeah,
then,
I'm definitely interested in that. Particularly if you're going to rag on Edison, because Edison was an asshole, from my understanding.
yeah. Well, I think the point is like he was less of an asshole than is often portrayed.
He wasn't as
Um,
much of an asshole.
well, he was still an asshole.
Okay.
It's not as bad, but they're all assholes, right? Edison, Tesla, uh, they're all dicks. The whole fucking lot of them, they're all dicks. Greedy, greedy, greedy.
Okay. Well, as
But
for
Edison wasn't as bad as made out. But that doesn't
interesting.
take away
Okay.
from the fact that he was an asshole.
Well, he electrified dogs, so I don't like him on
Yeah,
that score.
yeah,
So
yeah. But you know, Westinghouse was also an absolute dick. So. And J.P. Morgan pops up in the story. So,
well, yeah, there you go.
yeah.
All right. Well, I think I'm gonna close this out. So, um, again, thank you for coming on. I thoroughly enjoyed it. So, for all the rest of you out there, peace out. Have a good day.